In 2025, NASA's James Webb Space Telescope revealed a hidden secret destiny, a brand new moon orbiting Uranus.
In the silent darkness beyond Neptune, a secret waited for centuries. Uranus, icy, distant and shrouded in shadow, hid something no one had ever seen. For generations, astronomers believed the story was complete. 5 majestic moons circling in a stately dance, their names whispered across the centuries. Miranda, Ariel, Umbriel, Titania, Oberon. But the cosmos is never finished with its surprises. In 1986, Voyager 2 raced past Uranus, doubling the moon count in a single night, shattering the old portrait forever. Yet, even then, something remained hidden. Uranus's rings, dark as charcoal, thin as whispers, cast shadows where secrets could hide. It took a new kind of vision to pierce the darkness. The James Webb Space Telescope, with its golden eye, searched deeper than ever before. And there, in August 2025, a ghostly glimmer appeared. A 28th moon, no bigger than a city, revealed at last. Tonight, we uncover the story of this hidden world, a discovery that changes everything we thought we knew about Uranus, and about the secrets still waiting in the dark. Uranus, the 7th planet from the Sun, an ice giant with a bizarre 98-degree tilt. Unlike any other planet, Uranus essentially rolls around the Sun on its side. Known moons, the classics like Miranda, Ariel, Umbriel, Titania, and Oberon, plus a collection of small inner moons. Voyager 2's 1986 flyby gave humanity its best close-up views of Uranus, revealing rings, faint moons, and icy landscapes. But that was nearly 40 years ago. Uranus's rings, faint, dark, and incredibly thin. They scatter light, producing glare that makes faint nearby objects nearly invisible. That's why finding new moons here is so tricky. Enter the James Webb Space Telescope, humanity's most advanced infrared eye. Unlike visible light telescopes, Webb specializes in infrared light, which penetrates dust and reveals faint objects lost in glare. Webb's NIRCam, near-infrared camera, was the key. On February 2, 2025, Webb observed Uranus for nearly 7 hours. 10 deep exposures, each around 40 minutes long, stacked together to create the sharpest infrared view of Uranus ever captured. These long exposures are vital. Only with patient, sensitive imaging can a faint 10-kilometer rock be spotted against Uranus's brightness. Upon confirmation, the tiny moon received the temporary designation S2025U1, a standard astronomical convention. The S stands for satellite, 2025 for the year of its discovery announcement, and U for Uranus. The 1 signifies it's the first new moon found orbiting the ice giant that year. This formal name is a placeholder until the International Astronomical Union assigns a permanent one, which, following tradition for Uranian moons, will be drawn from the works of Shakespeare or Alexander Pope. Its estimated size is a mere 10 kilometers or about 6 miles across, so small you could walk its diameter in a couple of hours. This makes it one of the smallest known moons in the Uranian system. This size isn't a direct measurement, but a careful estimate based on its observed brightness. Astronomers used the James Webb Space Telescope to measure its faint reflected light, and from that inferred its size, a remarkable feat from over 2.7 billion kilometers away. S2025U1 orbits Uranus at about 56,000 kilometers from the planet's center, placing it deep within the complex ring system. It joins a crowded family of at least 13 small inner moons. Specifically, it's nestled in the narrow gap between its neighbors, Ophelia and Bianca. This region is incredibly dynamic, with these small moons acting as shepherds, using their gravity to sculpt and maintain the sharp edges of Uranus's faint rings. S2025U1 is the newest member of this delicate cosmic ballet. The moon's path is a crucial clue to its origin. Its orbit is almost perfectly circular and lies flat along Uranus's equatorial plane, the hallmark of a regular satellite. Unlike irregular moons, which are captured objects with wild orbits, regular moons are thought to have formed from a disk of material that once encircled their planet. The stable circular path of S2025U1 strongly suggests it was born right where we see it, coalescing from the same primordial debris as the rings. The evidence is subtle but undeniable. In raw JWST exposures, S2025U1 is a faint pinprick of light. The discovery was made by meticulously comparing multiple images taken over time. Using a technique known as blinking, astronomers rapidly switch between frames, making the moon appear to jump against the stationary background stars. It's a painstaking process of elimination. But when these frames are stacked into a composite image, the full picture emerges. Uranus, its glowing rings, and this tiny, hidden wanderer finally revealed. Glare problem. Uranus and its rings outshine faint nearby objects. Small size, at just 10 kilometers across, it reflects very little sunlight. Old limitations, Voyager 2, Hubble, and ground telescopes simply didn't have the sensitivity or resolution to detect such a faint body against the glare. Infrared advantage. Webb's infrared eyes plus long exposure time finally made the invisible visible. This discovery isn't just one more moon. It hints at a dynamic, evolving system. Uranus's inner moons and rings interact. Moons can shepherd rings, rings can feed moons, and collisions can reshape both. Finding such a small body suggests Uranus may have more hidden moons, perhaps dozens waiting to be found. It also feeds into bigger questions. How did Uranus form? How do ring moon systems evolve? How stable are these delicate gravitational dances? Comparing Uranus's moons with those of Jupiter, Saturn, and Neptune helps scientists see patterns and differences in how giant planets build their miniature solar systems. For now, the moon is called S2025U1, but the International Astronomical Union, IAU, will eventually give it a formal name, likely from Shakespeare or Alexander Pope characters, as per Uranus's naming tradition. Webb and other telescopes will keep observing, refining the moon's orbit, measuring its brightness, and probing its composition. Scientists believe more hidden moons might be lurking in Uranus's ring shadows. This discovery is just the beginning. It may also help explain how Uranus's rings formed, and whether small moons like S2025U1 are feeding material into them, or being shaped by the rings themselves. And so, our journey to the distant, enigmatic world of Uranus comes to a close. We've traveled across billions of kilometers, peered through the mists of time, and witnessed a moment of pure discovery. Let's reflect on what we've learned. The James Webb Space Telescope, with its unparalleled infrared vision, has once again pushed the boundaries of what's possible. By meticulously analyzing data from its near-infrared camera, astronomers performed a cosmic magic trick. They made the dazzling glare of Uranus's icy rings vanish, and in the darkness a ghost appeared, a tiny, faint moonlet, now provisionally named S2025U1. At a mere 8 kilometers in diameter, barely the size of a small town, this world had remained hidden in plain sight. For eons, it has orbited its parent planet in silence and shadow, a dark, likely icy rocky relic from the chaotic dawn of our solar system, tracing a path every 677 days. Its discovery isn't just adding a 28th moon to Uranus's family portrait, it's giving us a fossil, a pristine piece of the raw material that built the giant planets, a story that has been waiting 4.5 billion years to be told. Humanity has now read the first word of that story. And this brings us to the most profound takeaway of all. In an age where we gaze at galaxies from the dawn of time, it's easy to think our own cosmic neighborhood is fully explored. But this discovery shatters that illusion. Uranus, a planet known to us since 1781, a familiar point of light for centuries, still holds deep secrets. This tiny moon hints that the system of moons which sculpts the planet's delicate rings might be more complex than we ever imagined. It raises new questions. Are there more of these tiny moons? How do they interact with the rings? What can they tell us about the cataclysmic impact that may have knocked Uranus on its side? This is the true power of an instrument like Webb. It's not just about seeing farther, it's about seeing. It's about revealing the unseen details in the familiar, from the atmospheres of potentially habitable exoplanets to the birth of the very first stars, Webb is a relentless engine of surprise, and its work at Uranus is far from over. Future observations will aim to refine S2025 U1's orbit, study its composition, and continue the hunt for even more hidden companions. This discovery bolsters the case for a dedicated mission to the ice giants, a new frontier in our own solar system. Now, we want to turn the telescope over to you. This discovery proves our solar system is still full of mysteries. What do you think is the biggest secret still hiding in our cosmic backyard? Is it the elusive Planet 9, the potential for life under the ice of Europa or Enceladus, or something no one has even thought of yet? Share your boldest theories in the comments below. We'd love to hear what you think. And if you enjoyed this deep dive into the mysteries of our solar system, please show your support. Don't forget to hit that like button, subscribe to the channel, and ring the notification bell. It's the best way to ensure you don't miss our next journey into the cosmos. The story of science is a story of endless curiosity. Each answer we find only leads to more profound questions. So, until our next cosmic story, keep looking up, because the universe is always waiting to show us more.